Hello, student. Welcome to the topic network theorems. And in this session, we are going to study the reciprocity theorem, maximum power transfer theorem, and we'll see the its statement and proof. So here, the learning objectives are analyze the linear bilateral electrical networks using network theorems, and to study the reciprocity theorem, and to study the maximum power transfer theorem. And session outcomes will be, we'll learn what is the voltage divider rule and Ohm's law to calculate load current, and how to analyze the reciprocity theorem and maximum power transfer theorem. And also we will going to solve some problems on reciprocity theorem and the maximum power transfer theorem. And now I am going to explain these things on recap. And first we'll see what is a circuit. Circuit means when electrical components or devices are connected in such a way that there exists at least one path for the flow of current. That type of system is called as a circuit. So it is an interconnection of the electrical devices or components in such a way that there should be at least one path for the flow of current. That kind of thing is called as a circuit. And next we'll see what is a linear circuit. Linear circuit means in this circuit uh, the electrical components such as resistors, capacitors, and inductors are connected in such a way that their values are not going to change when the current changes its direction. Means when the current is when the current is flowing either in the clockwise direction or in the anti-clockwise direction, the values of these components should not change. That kind of circuit is called as a linear circuit. Non-linear circuit means there will the values of the uh, some components will going to change if the direction of current is changed. That kind of thing is called as a non-linear circuit. Then what is electrical network? Electrical network means when some components, electronic or electrical components such as resistors, capacitors, inductors, which are connected in some manner, it's called as an electric network. So electric network not necessarily be a closed path. So here current may or may not find some path for its flow, but circuit means always there will be a one path for the flow of current. That is the difference between circuit and electrical network. Next, we will see what is a bilateral network. Bilateral network, in case of bilateral network, bilateral components are present. What are bilateral components? Bilateral components are those which do not change their values when the current changes its direction. So when that kind of components are present in a network, that kind of network is called as a bilateral network. Then branch. What is branch? Branch means it is a part of a circuit where the current can flow. And next we will see what is voltage divider rule. The voltage divider rule tells that actually this rule is used to divide the voltage into some value. So this is generally done with the help of resistors. So this rule tells that the maximum voltage is divided if the resistance or according to the value of resistor, because the IR product decides the value of divided voltage. So higher the value of the resistor, higher will be the voltage divided in the network. So that is called as a voltage divider rule. And we have studied what is Kirchhoff's voltage law. Kirchhoff's voltage law tells that the IR products, the sum of the algebraic sum of the IR products in a network is equal to zero, or the or in other way, the sum of the algebraic sum of the IR products is equal to the EMF of the battery. In this way also we can tell, or we can state the Kirchhoff's voltage law. So next we will see again some of the definitions. Single source network, networks with a single voltage source and single current source is called as a single source network. Actually, don't uh, don't misunderstand here, because single voltage source and single current source both are same, both are same. So in simple way, if there is only one source in the network, it is called as a single source network. If there are more than one sources in a network, they are called as the multi-source networks. In this way, time varying elements, if the parameters of the network elements vary with time, they are called as time varying elements. For example, capacitor, if you take the capacitor, its capacitance value depends upon the flow of current, and when the key is switched on, the capacitor starts charging and its value go on increases until it reaches its maximum value. So initially, with respect to time, its value is changing. So that kind of elements are called as the time varying elements. Next, you come to the reciprocity theorem. Reciprocity theorem is very simple. If in a network, if in an electrical network, and there will be a voltage source at one place, and you measure the current in any branch, in anywhere in the network, and then if they are reversed, if they are interchanged, their values will be same. I will explain this with the help of the diagram next. And in simple words, you can state the reciprocity theorem as when the places when the places of voltage and current source, it is not a current source actually, it is the value of current where it is measured, there will be no source in any network or interchanged, the amount or magnitude of current and voltage in the circuit will uh, going to change. And this theorem is used for solving both DC and AC networks. Here we can explain this reciprocity theorem more clearly with the help of this diagram. And reciprocity theorem is used in bilateral linear network with which consists of bilateral components. I explained bilateral components means their values will not going to change if the direction of the current is changed. That is called as the bilateral components, and such type of circuits are called as the bilateral linear networks. Linear means voltage and currents will be proportional in the devices. That kind of circuits are called as the linear networks. And next, it is in this diagram you see voltage sources here, and you are measuring the current here in the stage one, and now you reverse it. In the place of voltage source is here. In the place of voltage source, you keep a current measuring device, and in place of a current measuring device, in this case, you put the voltage source, and when it is checked after replacing these things, what will be found is that the values will be same. That means the value of this voltage and current will be same in both the cases. So this is the meaning of reciprocity theorem. And in this diagram, this R1, R2, R3 are the resistors, and V is the voltage source, and I is the current source. And here I will explain what is the meaning of voltage source and current source. Voltage source means it is a two-terminal device which gives some fixed voltage, irrespective of the load resistance. It is called as the voltage source. And current source means it is again a two-term device which gives a variable current by keeping the voltage fixed. That kind of source is called as the current source. So it is clear from the figure that the location of the voltage source and the current through the branches may be interchanged without any change in the current. So we have interchanged the position of the voltage source and the current measuring devices. So this is the meaning of reciprocity theorem. And this theorem is applicable only to single source networks, not in the multi-source networks. So this is one limitation. There should be only one source to apply this reciprocity theorem. If there are two sources in the network, you cannot use this theorem. And second limitation is that the circuit should not have any time varying elements. As I explained, if the value of that component is changing with respect to time, that kind of components is called as the time varying components, and that kind of component should not be there to apply this reciprocity theorem. And there are these are the steps solving a network utilizing reciprocity theorem. Firstly, select the branches between which reciprocity has to be established. The current in the branch is obtained by using the conventional network analysis, or simply you can calculate the current, or simply you can measure the current using the help of any device like a meter. The voltage source is interchanged between the branch which is selected. The current in the branch where the voltage source was existed earlier is calculated. Now it is seen that the current obtained in the previous connection, that is in step 2, and the current which is calculated when the source is interchanged in step 4 are identical to each other. So these are the steps to calculate the or to verify the reciprocity theorem. Next, we will move to the maximum power transfer theorem, another important theorem in the networks theorems. And this maximum power transfer theorem tells that maximum power is transferred from a linear bilateral network to a load resistance when the load resistance is equal to the source resistance. So this you can look at this network. Here load resistance is there. Load is the one which consumes electrical power at the end. So this is the voltage source, and here one resistance is there. It is called as the Thevenin's resistance. So this Thevenin's resistance actually includes all other resistance excluding the load resistance. So we can say that this Thevenin's resistance is the total resistance of the electrical this circuit, excluding load resistance. So when this Thevenin's resistance becomes equal to the load resistance, then at that condition, the maximum power will be transferred to the this load. This is the meaning of maximum power transfer theorem. So here, consider the following Thevenin circuit. This is a Thevenin circuit, Thevenin's equivalent circuit. VTH is called as generally the Thevenin's voltage, and RTH is the Thevenin's resistance that can be calculated with the help of formulas. And RL is a load resistance, and IL is a current through the resistor, this load resistor RL. So when this experiment is conducted and when a power versus the load resistance is plotted, this in a graph, this kind of nature is observed. It is observed from this figure that the electrical power delivered to the load increases up to this point. That means up to the condition when RL becomes equal to RTH, the power delivered to the load becomes continuously rises, and beyond this condition again the power delivered to the load decreases as we increase the load resistance. So this shows that only at one particular value of the load resistance, the power delivered to the load will be maximum. That is the meaning of this theorem. And here derivation is there. Load current through Thevenin's equivalent circuit IL is equal to VTH divided by RTH into RL. This is obtained written to this Thevenin circuit. So just you apply the Ohm's law here. RTH is there, RL is there, and these two are in series. So the total resistance of the circuit is RTH plus RL, and this is voltage, and this is the current. So just apply the Ohm's law, and you will get this equation. IL is equal to V is equal to V by R. So IL is equal to VTH divided by RTH plus RL. Then by making use of the power delivered to the load, or I will make use of the definition of the power. As you know, the power is equal to I square R. The power can be calculated as a I square R. Just use that formula, and I square means you put the value of this IL, it becomes square into R. So take this as equation 1. Then to determine the resistance of the load at which the power transferred to the load is maximum, differentiate equation 1 with respect to RL and equate it to 0. This one. So we have to differentiate equation 1 with respect to RL. So it becomes dP by DRL. And why we should be equate this to 0? Because this is actually slope of the that curve, and the slope of this curve is 0 at maximum value is here. And at this point the slope becomes 0. So that point also corresponds to the point where the power delivered to the load is maximum. So that means slope is 0. Slope of this curve is 0 at this point. So we are setting this slope equal to 0. Then differentiate equation 1 with respect to RL. So these are the, and you are putting the this value. Here VTH is taken outside because it is a constant value, and only R is changing in this way. And you are setting this sending this VTH square into either LHS or RHS, that goes 0. So remaining is this thing, and differentiate this with the help of U by V formula. U differentiation of U by V. So just you apply it, you will get this one. That is uh, uh, differentiation of U by V means du. Differentiation of U multiplied by V minus V multiplied minus U differentiation of V divided by V square. That formula is applied here. So you are going to do, you are going to simplify this equation here. So RTH plus RL is common in both these two terms. You take it out, then write, and here RTH plus RL, one term get cancels. So remaining term you are writing here. Then you are sending this denominator to RHS, so that goes 0. That means this thing becomes equal to 0, and simplify this bracket, you will get RTH minus RL equal to 0. This implies that RTH is equal to RL. So that condition is achieved. To find the maximum power consumed by the load, substitute RTH is equal to RL in equation 1. So that maximum power becomes VHTH divided by RTH plus RL was there. Instead of RL, you are writing RTH whole square into RTH. So VHT square, and this RTH plus RTH becomes 2 RTH, and when you make it square, it becomes 4 RTH square into multiplied by this RTH, and 1 RTH get cancels. So lastly it is VTH squared divided by 4 RTH. So this is the formula to calculate the maximum power transferred to the load. Then total power generated by the source when RTH is equal to RL is calculated as P total is equal to I into VTH. So I is the total current flowing in the circuit, and substitute the value of I here and VTH here, simplify it, it becomes VTH square divided by 2 RTH. Then therefore the efficiency of the source is equal to eta is equal to p maximum divided by p total, and put these two values, simplify, it becomes equal to 1 by 2. 1 by 2 is nothing but 0.5, and that is multiplied by 100, so that gives 50%. So thus the efficiency is only 50%, as half of the power generated is lost at the terminal or Thevenin's resistance. Hence, load get only the remaining half of the power. And here is one example. Uh, with the help of this, we can calculate the, means this problem is based on the maximum power transfer theorem. So for the given circuit, calculate RL to transfer maximum power, and also calculate P maximum. So this is the circuit, and here you are calculating the first RTH. RTH is equal to RL. This is equal to R2 plus R1 or R3 divided by R1 plus R3. This is R1, R2, R3, and this is R2 plus R1, R3. Here, these R1 and R3 are in parallel, so their effective resistance R1 into R3 divided by R1 plus R3 is that, and substitute the put the values, it becomes 2.33 ohms. And next, to find out the Thevenin's voltage, use the formula V into R3 divided by R1 plus R3. Here you will get 1.66 volt. Next, to calculate the maximum power transfer to the load, VTS squared over 4 RTS, and put the value, it becomes 0.296 watt. So in this way, you can calculate or work out some problems. And summary of this session is that reciprocity theorem and maximum power transfer theorems are stated and illustrated. They are discussed. Limitations of the reciprocity theorem is discussed. Expression for maximum power and efficiency is also derived. So problems are solved on the maximum power transfer theorem. And here we'll move to some MCQ, whose theorem gives the condition to achieve maximum energy transfer from the source to the load. And out of these, maximum power transfer theorem gives uh, this idea about the amount of power transfer to the load. Next, efficiency at maximum power transfer is 100%, 150%, 50%, this, and the option as just now you saw, it is 50%. And whose theorem is applicable to single source networks? Reciprocity theorem. It is the limitation of the reciprocity theorem. Reciprocity theorem is applicable only if the source in the network is one. Reciprocity theorem is used for solving only DC networks, only AC networks, both DC and AC networks, neither this. So as you just now see, a reciprocity theorem is used for solving both DC and AC networks. And maximum power is transferred when these are the conditions as derived just now. The maximum power is transferred to the load only when RTH is equal to RL. So the answer is option E. And next, these are the reference books. Go through them. Okay. Thanks for listening.